Welcome, this is School of Magic, we're learning physics magical. Let's go on to question 3. So in question 3, you have a long object, you have something that looks like pivot at B, something that looks like pivot at A. You have C, you have a ball falling on this end, which is 50 centimeters apart. C and E is 25 centimeters apart. A and C is 45 centimeters apart. A rigid bar of mass. So this is a bar. This bar has a mass of 450 grams. So let's begin with extraction information. It's held horizontally between two supports A and B as shown. So it's held. This bar is held horizontally, means it doesn't move. That means it's stationary. You got one pivot here, another pivot on this side, therefore blocking it from actually turning. The support A is 45 centimeters from center of gravity C, so C is the center of gravity. Okay. And so center of gravity means that the mass, you actually have a force here. This is the force of the bar. From center of gravity C of the bar and support B is 25 centimeters from C, as shown in the diagram. The ball of mass 140 grams, so you have the ball. Mass of ball is equal to 140 grams. It falls vertically onto the bar such that it hits the bar at a distance of 50 centimeters from C, shown in the diagram. The variation with time t of the velocity v of the ball before, during, and after hitting the bar is shown. So you also have a graph. There is a velocity time graph that looks something like this, and then like this. And double check what is this velocity of the ratio with time t of the velocity v of the ball. So okay, so this is velocity of ball. Remember, sometimes you need to know what these objects are, so that you get a clear picture of what they represent. In this case, it makes sense. A ball falling onto the object, this is the falling part, this is before it hits the bar. And then you have this part where it is during the ball and bar colliding in contact. So we say this is the contact phase, and this is after the ball leaves the bar. So this part, ball heading towards bar, ball in contact with bar, ball leaving bar. Okay, once we got that, A. For the time that the ball is in contact with the bar, so this is talking about, please look at the part of the graph where they are in contact, which is this part here. Use figure 3.2, the graph, to show that the force exerted by the ball on the bar is 3 newtons. So it's a show question. We like show questions because the answer is given, so you can redirect your thoughts to find out how do you get this answer. You can cross-check answer immediately and know your workings. Right. So what again is this force exerted by the ball on the bar? It's worth only 1 mark. It's worth only 1 mark. So you want to find force. The only thing on your mind is resultant force is equal to ma. You have mass, you got acceleration. What is acceleration here? Acceleration is just delta v over delta t. Do we have a change in velocity? Yes, we have a change in velocity. And do we have a change in time? Yes, we have a change in time. So basically, we have the 2 components we need. One is delta v, and one is delta t. So that means we can find what's the resultant force. So we want resultant force of ball on the bar. This is the mass of the ball. In this case, the mass of the ball is 140 grams. We need to change the SI base because it's newtons, so 10 to the minus 3. What is our change in velocity? We like graphs because direction is very given, so we just follow whatever is given here. So, according to my picture, I say it's around 5.4 meters per second. Positive. Again, remember this is a change. Change means you are subtracting, so this is minus here. So let's check out what inside here. It looks like minus 4 meters per second. Okay, of this it becomes plus. The time, let's say the time for being at plus 5.4 meters per second, according to this graph, it looks like 0.56. So 0.56 seconds minus, at minus 4, it looks like it's exactly at 0.6 seconds. So make sure everything is SI base. This is meters per second, this is seconds. So you can either calculate with me, so you can actually pause the video and actually calculate this. I'll just check what the answer is for you. Hopefully, there's no need for me to check the answer because the answer is already here. So hopefully you get something that is around 33 newtons. Okay? So, let me double check again. Looks round-ish. So, if there's any more examples of the solution, provide some feedback so that at least I know what went wrong today. Now, that's done. We go to B. For the time that the ball is in contact with the bar, still, this component here, we're in contact. Use data from figure 3.1, which is the first figure, and A, which is here, to calculate the force exerted on the bar by the support A and the support B. So you want to know V1, what is the force at A? What is the force exerted by A? Sometimes it's better if we actually redraw this diagram so that everything becomes clear. Let's draw a simple diagram. We have C here, the center of gravity, which is the force of the bar or the weight of the bar. And you have the ball which hits the bar. That means the force by the ball is here, and this is 50 centimeters apart, as shown by this diagram. You want to find the force on A, you have a PE. So this is point B, and it is 25 centimeters apart. You have from, this is C to B, C to A is 45 centimeters. We want the force of A. So let's say we assume, just take FA to be in this direction. We have two variables, A and B. So in order to make this question easier to solve, we must choose a pivot. Remember, we deal with moments here, because this is not a point mass, it is actually a long object, a bar. So we need to choose a pivot. So we choose our pivot to be B. So this becomes our pivot. Remember again, when you chose a pivot, any forces acting on B is completely ignored. Why? Back to a simple concept, where what is moment? Moments is equal to force times perpendicular distance apart from the distance of force from pivot. So let us redraw that. So if we got B, this is point B, and the force is on B. First question asks, we know what force is, but what is the perpendicular distance of force F from B, from the pivot? Remember, F comes from B. Therefore, there is literally perpendicular distance in this case is equal to 0.